Hi everyone, welcome to this session. I'm Rohit Thakur. I'm a software engineer at Red Hat and I'm part of Ansible Network automation team. So in this session, I will talk about network automation and specifically network automation with Ansible. So let's see what we have in our agenda so that we can move further with our slides. So I will talk about why automation is necessary or important for networks, Ansible Network Automation, why Ansible Network Automation, and what sets it apart, and then network resource modules, which is really important, fact gathering, and then I will demonstrate the fact gathering and network resource module use. So let's move on with our slide. Okay, so why we need to automate our networks? So when we talk about old practices, or manual handling or managing the network, there are a lot of problems. So let's see. First one is legacy operational practices. So managing network hasn't changed much for quite a long time now, and most of network engineers are not much into programming, and still they are following legacy operational practices. So by legacy operational practices, I mean manually doing the SSH onto the device and executing the commands there, and then validating the changes manually, and then logging out of that device, which is really a difficult task, especially when you need to interact with so many devices, not just one. So next one is no source of truth, right? So multiple people could be working on same devices, and if someone make changes and someone else want to make changes and he or she doesn't know about the previous changes, then they need to check the state or see the changes manually, which is really painful task, especially when you're dealing with whole network and having so many devices, switches, routers, etc. And then comes the vendor specific implementations. So most of the vendors have implemented their technology in a way which is very specific to them. So if you are a network operator, you could have a like Vios or Cisco routers, and then maybe Juniper switches. And when you want to configure the network, you need to be aware of their specific technologies. So you need to have the knowledge of Cisco and Junos, Vios, etc. Next one is configuration drift. So what if like two or more people want to change same attribute? For example, let's say there are two people who want to change the router ID. So at the same time, so either one of them going to fail, and so that leaves one of them to not having configuration state to validate for actually. So that makes chances of making error quite high, so it's error prone as well. So I mean, to avoid these or to make the process much easier, we should find ways to automate our networks. So let's see what we have in our next slide. Okay, so why Ansible? What sets Ansible apart? So first of all, it's very simple. So especially, I mean, we also call it human readable automation. So, and that's because one doesn't need to be have that special coding skills, right? So all you need to do is you should know how to write your playbooks, and that too you should have the knowledge of YAML, so which is quite similar to, I mean, English language here. And then despite of being just simple, it's also quite powerful, and you could orchestrate whole network. You could automate the network, manage all IT infrastructure there, and basically it has agentless architecture, so you don't need any special agent running there. And it uses SSH or Panoramico based connection, and so basically it establishes connection with the device and execute the tasks there. So let's see what we have in next slide here. Okay, so basically when we talk about Linux automation and we talk about network automation. So how these two are different. So when we talk about Linux or Windows-based automation, in that case, module code is copied to the managed node and executed there and then removed, right? So I'm assuming that you have the knowledge of terms like control node, managed nodes. So basically, control node will be the node on which you will be having Ansible installed when it comes to network automation, and your managed host, the node you want to actually manage. But I mean, if you're not aware of these terms like module, manage node, control nodes, play, inventory, config, I think you should check out our previous videos, meetup videos as well. So maybe we can post the link for that as well. Let's just for now concentrate on the how these two are different. When it comes to network automation, module code is executed locally on the control node. So, and that is why, because many of the network devices, they don't support Python yet. And that's why everything is done on the control node, and there will be like commands will be formed, which are basically supported by the network platform, and that ultimately got executed on the device. So let's move on to next slide here. Okay, so these are some of the like common cases. I mean, there are a lot of use cases which are not mentioned here. It's just to give you an idea what could be done with Ansible. So you could ensure that specific service is present or absent. You could enable some services, or you could disable them. You could manage the firewall access lists, for example, backup and restore device configuration, or you could also upgrade the device OS as well. So let's move on to next slide now. Okay, Ansible Network Resource Modules. Okay, so this one is really important. So network resource modules are intentionally scoped to configure a single resource and can be combined as a building block to configure complex network services. So basically, network device separate the configuration into sections such as like interfaces, VLANs, it could be static routes, it could be OSPF routes, etc. And this basically apply to a network service. So Ansible Network Resource Modules take advantage of this to allow you to configure subsections or resources within the network device configuration. So network resource modules provides a consistent experience across different network devices, right? So the modules have written in a way so independent of the devices, or basically you don't need to worry about what's there under the hood. So the feel of using those resource modules will be same. So that is the ultimate goal here. So let's move on to next slide now. Okay, so before discussing the resource module further, let's discuss about the fact gathering part, which is also very important, and then we can carry on with our resource modules there. So basically, let's face it, pulling facts from network device can be very hit or miss activity. Network platforms have various degree of abilities when it comes to fact gathering, with little to no ability to parse and standardize the look and feel of the data into key value pair. So in a nutshell, pulling facts from devices and normalizing its data into key value pair is extremely important for automating at a scale, but difficult to do across multiple vendors and network platforms. Okay, so pulling facts from device and normalizing its data into key value pair is extremely important here. That is like which is the most important part here when it comes to fact gathering. And so let's see what we have here in these points. So I have already discussed the collect facts from the network devices. So the facts means okay, I'll just show you. For example, these facts could also cover, apart from the configuration, like what are the interfaces configured, what are the L3 interfaces configured, what sort of static routes are added and all that. We could also fetch the basic facts like model, version, release and all that. Second one is places the facts gathered in the fact tree keyed by the respective resource name. So the gathered facts are basically structured in a format like key value format. So collects a base set of facts from the device. So this is what I just mentioned, that it will also collect the base set of facts from the device like model number, version and all that. And again, allow, enable or disable collection of additional facts. So you could also control what sort of resource module facts you want to fetch. For example, if you only need interfaces or L3 interfaces facts, you could mention only these two under the network resources. So let's move on to this slide now. Okay, so notice how Ansible pulled the native configuration from the voice device and converted it into structured data here. So that is for use as a standard key value pair for additional follow-on tasks and activities, right? So the interfaces facts can be added to your Ansible inventory and immediately or used later as the input for the voice interfaces resource module without being manipulated or transformed here. So we could see the ultimate structured output here. So we have a key Ansible facts having key value attributes, Ansible net API, which is like CLI conf here, and what network resources facts we are gathering. So we are gathering facts for interfaces in this example. Oops, sorry. Let me go back. Okay. And then this is a part of basic facts here, like host name, model, Python version, serial number, system version, etc. And here you could check out, you could see Ansible network resources. So these are the facts for interfaces. You could see that it1 is there and local interface is there as well. So let's move on to next slide and let's see what we have there. Okay, so this is basically the snapshot of the task I'm going to execute. So I will be demonstrating this. So basically in my task, I'm gathering basic facts and then I'm gathering the facts for the interfaces resource, right? So, okay, so let me show you. Okay, here we are. Let me just clear this. So first I'm going to manually SSH on the device. Okay, so let me execute show version. So this is iOS 118 Helium, and you could see other information here as well, model and UUID and all that. Okay, to see the running configuration, the command would be show configuration commands, and you can just simply press enter. Okay. So this is the running configuration for this voice router, and you could see the interfaces here, and you could see the attributes configured like description, duplex, hardware ID and all that. So in this demonstration, I will be fetching the basic facts, like some of the basic information, and then when it comes to gathering facts for resource module, I will be gathering facts for interfaces or L3 interfaces. So I'll show you what is the difference between interfaces and L3 interfaces facts. And first, let me show you the playbook or task one more time. Okay. So basically I will be gathering basic facts, and then I will be gathering facts for interfaces resource module and L3 interfaces as well. So let's just run this playbook and let's go through the output. after that. Okay, so we can see it was successful run and nothing has changed. Change is 0 or false. So okay, so this is the Ansible fact key. You could see that we have the API CLI conf, and then what sort of resource specific facts we are gathering, that is interfaces. And for L3 interfaces resource, you could see the host name, the model, serial number, and net version, and all that. So part of as a basic facts. So now let's see what's there in facts which are specific to particular resource. So first one is interfaces resource. So we can see that description is there, duplex, name of the interface, which is more like a primary key here, and then speed. So similarly for H1, H3, and H0 and local interface here. And then next resource module we mentioned in our task was L3 interfaces. So for L3 interfaces, the only attribute there is IP address. It could be v4 or v6, but in our case only v4 was configured there. So, and that too, it's showing address as DHCP, and that is because the IP address was assigned by the DHCP service there. Okay, so that's pretty much we have for facts. And let's go back to the slide and see what we have next there. Okay. Let's go to next one. Okay. So now that we have pulled the facts and normalized the data and put them into a standard internal data structure schema, we now have an on-box source of truth, which is really great. But the problem now is that we still need a method to take key value pairs as source and convert them back into the specific configuration that the specific device platform is expecting, right? So platform specific modules were developed to satisfy these new requirements of the fact gathering and normalizing activities. So you could see here that this is the structured data input, and then Ansible resource module act on this, and ultimately the commands which are basically supported by the network platform got executed on the device. So I mean, this is the flow. Let's see what we have in our next slide here. Okay, so basically with the resource module we will be providing configuration, and then we want to perform some sort of action or operation on that provided input. So basically the action or operation we want to perform, we can specify through state here. So state could be of there are like 7 operations for our basic. So first one is merged. The on-device configuration will be merged with provided configuration. So it's like just adding the configuration, right, to the running configuration. So if, for example, if you want to add a particular IP address, you could simply use merge operation and add that particular IP address there. And then it is idempotent. All the operations are idempotent. So for example, let's say you have already added one IP address and you are again executing that task with merged operation. So in that case, there won't be any change applied to running configuration. So which means that is idempotent. Okay, so next one is replaced. The on-device configuration subsection will be replaced with the provided configuration subsection in the task. So basically it is if you want to edit a configuration, running configuration, you could for a specific resource, right? So in that case, you could use replaced operation. Next one is deleted. So the configuration of the provided resource will be deleted or will be defaulted, right? That totally depend upon the what a platform allows. Next one is overridden. So the on-device configuration for the resource will be overridden with the provided configuration in the task. So basically, when we talk about replaced operation, it is specific to particular subsection, but overridden affects whole configuration specific to particular resource, right? We are not talking about a subsection in that resource. We are just talking about whole resource there. So for example, if we are using overridden operation for interfaces resource, then it will affect all the interfaces, not just the one which are mentioned there, right? So let's move on to next slide here. Okay, so there are additional operations as well which we have introduced in most recent release. So first one is gathered. So this displays the resource detail gathered from the network device and accessed with the gathered key in the result. So gathered is very similar to what we have for fact gathering, right? But the difference is that the output will be bounded to a gathered key there. Next one is rendered. This renders the provided configuration in the task in the device native format. Ansible return this rendered configuration in the rendered key in the result. So one more thing, rendered basically for rendered, no connection is established with the device, so you could simply run this in offline as well. And for render, the input would be a structured input, config input, and the output would be the actual commands equivalent to that structured input, which are basically supported by the device, right? So I'll show you the what are the commands. I mean, how why I'm mentioning the commands which are supported by the device. So when I will be demonstrating these operations, I will show you what I exactly meant by the commands here. Next one is parsed. So Ansible passes the configuration from the running configuration option into the Ansible structured data in the parsed key in the result. So basically with parsed, it is quite opposite to what we have in render. So for parsed, the input would be a running configuration or the commands which are there in running configuration on the device, and the output would be the equivalent of that running configuration, but that would be in structured key value format there, right? And again, just like rendered, it could be executed offline as no connection is established to with device in this case. So let's move on to next slide and let's see what we have there. Okay, so it's time for the demo. So let me show you how we can execute all these operations. Okay, so let me show you the playbook first. Let's just close this, and I'm going to use GVim here. Merged, replaced, overridden, and deleted. Okay, so this is the playbook for merged operation, and I have used wires interfaces, resource module, and then for config key, you could see I'm providing the configuration here. This is the configuration I want to actually merge to the running configuration. So basically I'm providing ith1, ith0, ith2, ith3 interfaces, and I want to configure MTU for ith1, description, and then description for rest of the interfaces here. So let's run this playbook and let's see what we get in output. Okay, so first you can see it was successful run, then something have changed there. So change equal to 1 means that changed was true. It doesn't mean that only one change was there, right? I mean, that's pretty common. So let's go through what we have in output. So there is a key before, and if you see, so it has the configuration actually which was there on the device before executing the task we had or we have in our playbook there. So this was the configuration, I mean, before anything was changed on the device. So you can see that description was demo do not save for all the interfaces here. And let's move. Okay, so here we have after. So for after key, you could see that so basically after has the configuration, basically the state the device changed into after our task got executed, right? So you could see that description has changed. It's configured by Ansible now, and again for eth0, eth1, and eth2, and we have successfully changed the MTU value as well for eth1. So, and then these are the commands. So I was talking about, like, for render, the structured input would be something, the input would be structured, and then output will be the commands which are supported by the device. So ultimately, resource module, for resource module, we have this input here, and resource module process on that provided configuration and generate the commands which are supported by the device and which needs to be executed on the device. So the command list is showing actually the commands basically which have been executed on the Vios router here. So if you try to run this one more time, it won't change anything, as we already have this configuration applied on the device. So it will simply you can say that change, you can see that change is false here, and there is only before, right? Why we don't have any after list or dict here? Because nothing has changed there, right? Okay, so let's see what we have in our replaced operation now. Okay, so in replace operation, I just want to actually edit the Ethernet 1 attributes. I want to change the MTU value to 1300, which is 1500 there right now, and then description I want to keep it same. So basically with the replace, we should at least have one command which should set the MTU to 1300, and then it should delete the attributes of it1 which are specific to Vios interfaces resource and which are not here, not in this task, right? So let's execute this. Okay. So as I mentioned before, we'll be having the configuration which was actually there before executing our task, and then after is having our changes in this. So we can see that MTU has changed to 1300. Rest of the attributes like duplex and speed are not there because we haven't included those in our particular task here. So, and rest of the interfaces haven't got affected in any way. So for replace, the scope was only to this subsection here, and so again it is also idempotent, and these are the commands which actually formed internally and got executed on the device. So again it's idempotent as well. If you try to rerun this, it won't change anything. So I'm going to move on to overridden here. Okay, so overridden works quite similar to replaced in a way, but the scope would be the specific resource here. So in our case, if I am having these attributes here, it will basically affect all the other interfaces as well. So the interfaces like eth1 and eth2 are not present here. So in that case, any attributes which is there in running configuration will be deleted, right? So let's try to run this. Okay, let's quickly go and see after. So you could see that for it2 we don't have any other attributes like description and all that. Similarly for it1 and for it3 and it0 we have the attributes which were there in our task. So and these are the commands which got executed on the device ultimately. Okay, so now let's see what we have in deleted operation. So deleting here means it won't delete the interface. It will simply delete the attributes which are specific to virus underscore interfaces resource module. So in this case, so I have mentioned it1, it2 and it3. So maybe I can mention it0 as well. So let's just stick to these. Okay. So in this case, it should delete the attributes like description and all that, which are specific to virus interfaces resource module. So let's try to run this. Okay. So let's see, we have it1, it2, it3 enabled, and it0 wasn't mentioned there, so that's why it0 is having attributes which are specific to interfaces, and rest of the interfaces doesn't have anything. It's just it's physically present there, so that's why we have those interfaces in this list, and you could see the commands which got executed on the device. So this is pretty much with all these basic operations, and for rest of the operation we will cover that when we will talk about the collections and we will move on to the latest release. So that's pretty much I had for facts gathering or resource modules in this session. So please stay tuned for future sessions where we will be having more talks about like latest resource modules, for example OSPF, static routes, ACLs, and then we will talk about the collections as well. So let's go back to our slides and see what we have there. So network operating system support. So currently we support Arista EOS, Cisco IOS, Cisco IOS XR, Cisco NXOS, Vios, and Juniper Junos, and others are supported like on community driven. Okay, so these are the some of the modules which we have already. So you could see for Arista EOS we have interfaces, Alto interfaces, and similarly for iOS, Junos, and if you go forward, Cisco iOS, NXOS, Vios. And there are other modules as well, especially with the latest release like OSPF, static routes, ACLs, firewalls for Vios. So those are also there. So that's pretty much I had for this session. I hope you have learned something here, and do let me know if you have any questions or suggestion. You can reach to me. So thanks for having me here. So thank you guys.